Good morning, 6th grade. Happy Monday. I'm going to start by going over the follow-up question from last week regarding unit rates. A 6th grade math teacher can grade 25 homework assignments in 20 minutes. Is he working at a faster rate or slower rate than grading 36 homework assignments in 30 minutes? So let's look at some strategies. Teacher 1 grades 25 assignments in 20 minutes. Teacher 2 grades 36 assignments in 30 minutes. So somehow we need to make these ratios equivalent so that we can compare one teacher to the other. So one way to do this is to make them equivalent ratios. So if I wanted to continue counting by minutes, I could go 20, 40, 60 minutes, 80. Okay? Now, if I do the same thing with counting out 25s, I could do 50, 75. I don't even need this 80 for a second. Let's just stop there. On this side, I can count by minutes and go count by 30s, 30, 60, 90, and here count by 36. 36 plus 36 is 72. Okay, oops, that's kind of messy. Let's try again. Is 72. So now, look, we have one part of the ratio to be the same, which is 60 minutes. So here, 60 minutes, the teacher can grade 75 assignments. So in 1 hour, teacher 1 can grade 75 assignments. In one hour, or 60 minutes, teacher 2 could grade 72 assignments. So we could see that teacher 1 is faster. Another way we could do that is using the unit rate, is to figure out how long or how many assignments can the teacher grade in 1 minute. So if I wanted to set this to 1 minute in both examples, I'm dividing the 20 by 20 to get 1, and 30 divided by 30 to get 1. On the same side here, I would have to do the same thing to the other side of the ratio and divide 25 by 20, which is a long division problem that we can do. 25 divided by 20. It can't go in. It could go in one time. Get 20 with a remainder of 5. Oops, it's not what I wanted to do. The remainder of 5. Let's erase this. Let's go back to normal. Move this up here. There's not enough space. We could do 25 divided by 20. When we do that, it wouldn't even matter to me if you did it on a calculator, because I know you could divide that out. So we could see 25 divided by 20. I just ran out of space. And I get 1.25. So this teacher can grade in 1 minute 1 1/4 assignments. 2.5, 25 cents, 1/4. Same thing here. I can do 36 divided by 30. Doing the same thing to both sides of the ratio. 36 divided by 30 is 1.2, or 1 2/10. So this teacher can grade in 1 minute 1 2/10 assignments. So here you could see teacher 1 grades more in 1 minute, so they are faster. So this is two ways to show you. We could have gotten equivalent ratios by getting them both to 60 minutes, or we could have solved for the unit rate. Either one, teacher 1 is faster. All right, here's my warm-up problem for today. The original price of a scarf was $16. During a store closing sale, a shopper saved $12 on the scarf. What percentage discount did she receive? Explain or show your reasoning. Remember, when we talk about a percentage, we're talking about a ratio or a fraction out of 100. So let's pause. Let's try and solve this problem. All right, let's go over this. So I'm going to write this as a fraction of what the shopper saved. So they saved 12 out of $16. That's what they saved. That's not what they paid for this. They saved 12 out of $16. So I'm trying to think, how can I get that to a fraction or a ratio out of 100 that makes sense? So the first thing I'm going to do is I'm going to simplify this to something that I know well. And I know that a factor of both 12 and 16 is 4. So I'm going to divide the top by 4 and the bottom by 4. And I get an equivalent fraction that's equal to 3/4. Oops, you can't see that well. Equal to 3/4. 12/16 is equal to 3/4. Now, you might know, looking at that, 3/4 is like 3 out of 4 quarters of a dollar, what percentage that would be. Or what I can do is, if you don't know off the top of your head, I can set it equal to a fraction out of 100. So now I can ask myself, 4 times what gives me 100? 25. That's like taking a quarter times 4 gives you $1 or 100. So I'm going to do the same thing on top. 3 times 25. And I get 75. So what percentage discount did she receive? She received a 75% discount on these items. Okay? All right, so here's our challenge for today. It's called Earning an A. Alyssa took a math test with 20 questions, and she answered 16 questions correctly. In order to get an A, she needs to answer 90% of the questions correctly. 1. Did Alyssa get an A on this math test? Explain. If Alyssa did not get an A, how many questions would Alyssa need to answer correctly in order to get an A? On the same exam, Alyssa's friend Jessie answered 3 times more questions correct than incorrect. Who got a higher percentage of the test questions correct? Alyssa or Jessie? Now would be a good time to pause this and record things that you notice and wonder. So please take 5 minutes and record notices and wonders. Here are some things that I noticed and wondered about this problem. Let's start with notices. Alyssa needs to get a 90 on her test to get an A. She answered 16 out of 20 correctly. She answered 4 questions incorrectly. Alyssa's friend Jessie answered 3 times more questions correct than incorrect. Some wonders. Did Alyssa answer enough questions to get an A? If not, I wonder how many more questions Alyssa needs to get right. Did Jessie do better or worse than Alyssa on the test? How do we know? I wonder what strategies we can use to figure this out. A double number line, a tape diagram, an equation of some sort, So here is the problem again. I would like you to read it carefully, multiple times, and try to solve it on your own using any strategy we have used before related to percentages. If you need to go back, here is the problem to go back to. All right, now I'm going to show you multiple strategies on how you can solve this problem, including what percentage Alyssa got right on the test, as well as if she needed to answer more questions to get the grade of an A. So the test was made up of 20 questions. So I'm going to first start with this strategy of a tape diagram. So this tape diagram has to add up to 20 questions. So if I'm thinking about this for a second, she got 16 out of 20. So what could I count by that gets me up to 20? And that's enough to give me 16. Let's see, I can count by 4s. 4, 8, 12, 16, 20. So each of these 5 boxes is worth 4, right? Think about it. And I could count 4, 8, 12, 16, 20. 20 is the whole test. If she got 20 out of 20, she got 100%. So I'm going to use that in comparison to make this into an equivalent ratio out of 100. So look, what I'm going to do the same thing. 4, 8, 12, 16, 20. This is how many Alyssa got right. We know 20 out of 20, the whole thing would be 100%. So I'm going to put 100 here in this box. And think about it. If I'm taking 100 and dividing it by 5, what am I counting by? I'm counting by 20s. So I'm going 20, 40, 60, 80, 100. So if Alyssa got 16 out of 20, that's an equivalent ratio with 80 out of 100, which gives me a percentage of 80%. So Alyssa got 80% on this test. Let's look at it another way, using a ratio table. So Alyssa got 16 questions correct out of a test of 20. I'm going to just count up until I get to 100 on this side. So I'm counting by 20s. I'm making an equivalent ratio table. 20, 40, 60, 80, 100. Now, I can count by 16s, right? So 16 plus 16 is 32. Yep, let's try it. Plus 16 is 32. 32 plus 16 is 48. 48 plus 16. 1 plus 4 is 5. 5 plus 1 is 64. Oops. Let's make that neater. Let me. Let's try just rewriting it. 64. 64 plus 16 is 80. So here are equivalent ratios. These are all equivalent. 80 to 100 is the same as 16 to 20. I just made a table of equivalent ratios to show it. Now, how could I use a double numbered line strategy? Same way as I did with the ratio table. I'm at 0, 0. Okay, I have this could be, my first line could be my questions that are correct for C. My second line, questions on the test. So the first mark I have is 16 to 20, which is the equivalent ratio that I know, and I want to see what percentage that is out of 100. Keep counting by 16s. 32 to 40. 48 to 60. Okay? 64 to 80. 80 to 100. So if these are all equivalent ratios, 80 out of 100 is 80%. So 16 out of 20 is also 80%. Now, let's do this using equivalent fractions, which are the same thing as equivalent ratios. 16 out of 20. We could just set it equal to a fraction out of 100, and in this case, it works well. 16 times 5 gives me 100. 16 times 5 gives me 80. So this is equal to 80%. That's what she got on the test. Now, let's look at this one more time. This is what I could have done here in my ratio table if I didn't want to skip counting. 20 times 5 gives me 100. 16 times 5 gives me 80. So 80% is a B. She did not get an A on this test. Get all the strategies that we have to show it. She did not get an A on this test. She needs to get a 90 to get an A. So there's many ways you could look at this. So let's try this. If we know she needs to get 90 out of 100 to get an A, and there are 20, and there are 20 questions on her test. Again, this is another way to do equivalent fractions or equivalent ratios because we know fractions are a way to record ratios. We could do again, 20 times 5 gives me 100, okay? So what times 5 gives me 90? Or I could do it the opposite way. 90 divided by 5 gives me what? 18. So let's prove it over here, in case you don't believe me. 18 times 5 times 5 is 40, 5 times 1 is 5, plus 4 is 90. So she needs to get an 18 out of 20 to get an A. Which means if she originally got 16 questions out of 20 correct, she needs to get 2 more questions correct. All right, now let's look at her friend Jessie. In the problem, it says, Jessie answers 3 times more questions right than wrong. So that's a ratio of 3 to 1. She gets 3 right for every 1 wrong. That's 3 to 1, 3 times 1, 3 times more correct than wrong. So that's a total of 4 questions, okay? So if we model this here, and this is 4 questions, she gets 3 right. If each of these are worth 1, she gets these 3 right. Now, that doesn't work if I want to go up to 100%. So let's imagine this. If this is all the ones, and this is going to be 4, and I count 1 question, 2 question, 3 questions, 4. This is the amount she gets right. The 4th one she gets wrong. But I want to convert this into something out of 100. So now I'm counting by I'm splitting 100 into 4 pieces. So what is that? 25, 50, 75, 100. In this way, if she gets 3 out of 4 questions right with a ratio of 3 to 1, we can see she gets a 75% on the test. Let's look at it this way. If she gets 3 questions right out of 4 on the test, we are trying to get up to 100. I could count by 4s. I could do this in lots of different ways. There's many ways I could do this. Now, I could do 4, 8, 12, 16, keep going. I would be here a lot, or I can think about it using the ratio table in the same way I did before. 3 to 4 that are right. I can do another one. Let's come up with something in the middle. Let's see, I could do 25, 4, 8. We want to do it by 100, we could just do it this way. 4 times 25, 3 times 25 gives me a ratio of 75 over 100 using a ratio table. 3 questions correct, 3 questions on the test. So 3 to 4. And again, I just want to show you something. This would also give me equivalent ratios. If I went 6, 8, these are going to be equivalent to 75 to 100. 3, 6, 9, 9, 12. If I keep adding, 3 more, 12 to 16, these are all equivalent ratios that would get me to 75 over 100. Okay, and the way we could figure them out is if I reduced any of these, like let's say take 12 out of 16, if I reduce this by dividing it by 4, which is just 4 times as much, I would get 3/4, which is the same thing as 75 over 100. So now if we look at it from a percentage perspective, you might not have needed to do this. You might know that 3/4 is 75% because it's like quarters with a dollar. 3 out of 4 quarters is 75 cents or 75%. Or you might needed to have set it equal to a fraction out of 100, which is the same thing as a ratio out of 100, multiplied the top and the bottom by 25 to give me 75 out of 100. So as you can see, Jessie scored lower than her friend Alyssa. She got a 75%. All right, so now that we've finished this problem on percentages with the test, here are some of my reflections. To solve a percentage problem, we can use a tape diagram, a double number line, and a ratio table. A percentage is a ratio out of 100. So we're just looking for equivalent ratios that is equal to a ratio out of 100. To solve percentage problems, we could look at ratios that are equivalent to the ratio out of 100. Here's the follow-up. Follow-up 1. Jane paid $40 for an item after she received a 20% discount. Jane's friend says this means that the original price of the item was $48. How do you think Jane's friend arrived at this amount? Is her friend correct? Why or why not? Now would be a great time to pause the video and try to solve this problem on your own or come back to it in a moment. Questions. If you have questions about anything I discussed or have answers to the problems I left you to solve, please email me or Mr. Lengthy your responses or send us a message on Dojo. I will respond to your messages in my challenge for Wednesday, not Monday. Have a great start to your week. I miss you all a lot. Keep me posted on how you're doing. Look forward to hearing from you. Goodbye. I apologize for my rudeness, for my barking and my howling. Now I put myself to sleep because Miss K was too busy recording this video to play with me. So I'll take a nap instead. Hopefully she'll come back and play with me later.